Hello, this is my 6.3 numerical model of biomechanics. So, biomechanics is analysing the forces which create motion within the body. It involves the study of kinetics, which are forces involved in the movement of an object, and kinematics, which is the motion and change of position of a body or object. The numerical model is used in relation to analysing biomechanics of a sport performer. It uses numbers and units to represent sporting actions, and these are presented in velocity, speed, displacement, distance, and acceleration. The model will be explained by using examples from basketball. So, kinetics are the forces that are involved in moving an object or body. For example, in basketball, the ball only moves because of a force from a hand pushing it towards the floor if you're dribbling it. Kinetics involve both linear and angular kinetics. Linear kinetics include rectilinear and curvilinear and are force, gravity, mass, and weight. For example, the force projected on a basketball causing it to bounce. Angular kinetics include torque and movements from levers. For example, muscular contractions pulling on tendons, pulling on the bone, which causes the creation of movement. So an example of that would be like the tricep brachii contracting eccentrically to extend the elbow in order to push the ball to the floor and cause it to bounce. A projectile is an object which moves under the influence of gravity. For example, a basketball travelling through the air would be pulled towards the floor due to gravity acting on it. Kinetics is the change in motion of a body or an object. It includes the direction, speed, distance, which it will take. Linear motion is motion in a straight line. So it's when every part of a body or object travels in a straight line with the same velocity. For example, a skier going down a ski slope, all their body is moving in the same direction at the same speed. Curvilinear motion is movement in a curve. So, for example, a cricket bowler swinging their arm in a bowl is their arms moving in a curve. Angular motion is movement around an axis. So, for example, a gymnast rotating around a bar, the bar being the axis and the gymnast rotating around it. General motion is linear and angular motion combined together. So, for example, a basketballer running down the court, their arms are moving angularly, but their whole body is moving all at the same speed and in a straight line. The numerical model is created through numbers, but should be produced upon information found on the internet. For example, online journalists written by biomechanists who have analysed the techniques of those who compete in basketball, and techniques used by elite athletes because they're obviously good at what they do, and therefore the basketballer is able to learn from what the elite performer has done on how to improve their performance. It can also be generated through models found in academic articles and literature-based. Fact sheets, reports, textbooks, and information booklets. And if you're studying basketball, which we are, they would all be on basketball. And these methods can be combined in order to generate the perfect numerical model. So there are advantages and disadvantages of using the numerical model for sporting analysis. So the advantages are that it's helpful for elite performers because any slight modification could be the difference between them winning a gold medal or them scoring the goal. It has been shown that analysing biomechanics of a performer can lead to performance improvements. It allows an identification method for any problems in a technique that need to be changed. It helps design new equipment. It allows injury prevention, and it's based upon models which have the correct techniques and everything works well for them, so it's quite accurate. There are also disadvantages though, which include it's really expensive because you have to pay for equipment and specialists. It's quite time consuming, like setting all the equipment up, and a simple coach might not have time to take their athletes there and like analyze their movements. It requires specialist equipment which needs to be like used properly, and obviously that you need specialists to be able to do that. Results may be complex to understand, so you'll need someone who understands what every figure means. It requires a lot of knowledge after obtaining the results, which is mentioned before. It needs to be done in a controlled environment because of all the equipment, but this might not represent like how the athlete will be performing in their sport. And it uses mathematical methods which are hard to relate to the performer because they're not really, might not be a mathsy person. So there's two types of ways you can measure kinematics, and they are scalars and vectors. So a scalar is a value which only has a magnitude, for example, how far a basketball has travelled. Distance, speed, mass, inertia are all scalars, and they will only give information on how large, fast, or far an object or body has travelled. This differs from a vector because it's a value which has a magnitude and a direction. For example, it will explain how far the basketball has travelled and in what direction. Distance, velocity, acceleration, deceleration, weight, and momentum are all vectors because they give the value of how large, fast the object is travelling and what direction it is travelling in. Linear motion and speed and velocity. So speed is how quickly a body or object moves. It is represented by an S and is measured in meters per second. Because it doesn't give a direction, it is a scalar. The average speed is calculated by total distance divided by the total time. So, for example, a basketball may travel 20 meters in 4 seconds, therefore it will be traveling at 5 meters per second because 20 divided by 4 is 5. Velocity is how quickly a body moves in a resultant direction, and therefore it's a vector. It is represented by a large V and measured in meters per second, stating positive or negative direction. To calculate the average velocity of an object or body is the total displacement divided by the total time. For example, a basketball may travel at a speed of 20 meters per second because they had a displacement of 40 and it took the ball 2 seconds to get there, and 40 divided by 2 is 20. The graph on the left shows the velocity of the performer, how they went through a 20-meter sprint. There is a steady increase in velocity between seconds 0 to 1.5, and as it reached 3 meters per second in a positive direction, and then a drastic increase after running for 2.5 seconds to 8.2 meters per second, and then the performer slows down slightly, finishing the final meter at the speed of 6.1 miles per second. So distance and displacement. Distance is the total path an object or body has taken. It is represented by the letter D and is measured in meters. For example, a basketballer may travel a distance of 18 meters when driving down the court because he is moving around players. Displacement is a change in position or it's just position really, of a body, or the straight line difference between the starting point and the finishing point. It is represented by the letter S and is calculated by the difference in the final position and the initial starting position of an object or body. For example, the basketballer may have travelled a distance of 18 meters whilst weaving through different players, but has only got a displacement of 15 because where they started was 15 meters from where they finished in a straight line. Acceleration is the change of speed or velocity of an object or body. It is a vector because it states whether it is in a positive or negative direction. If it is negative, it means that the object is slowing down in that direction, in the forward direction. Acceleration is calculated by the change in velocity divided by the time taken to cover the distance. For example, a basketballer may travel 40 meters in a time of 5 seconds, and therefore is accelerated at a speed of 8 meters per second squared, because 40 divided by 5 is 8. The graph below shows the acceleration of the performer as they ran through a 20-meter sprint. In the first 1.6 seconds, they accelerated at a speed of 2 meters per second, which was then increased further to 8.5 meters per second squared at 2.25 seconds, before deaccelerating at a rate of minus 2 meters per second squared and continuing to do so at a speed of minus 0.6 meters squared. So force is the mass of an object multiplied by the object or body's acceleration. Force is needed to move all objects and bodies. It is unseen, but the actions resulting from a force are seen. For example, a ball being passed or a basketballer jumping is always either a push or a pull. There are 4 types of forces. A horizontal force is a force which works in a horizontal direction, so friction and air resistance are examples of this. Vertical force is a force which acts vertically, so weight and gravity from an object's mass. An internal force is a force within an object, so muscle contractions pulling on tendons. And an external force is a force which is initiated from outside an object, so gravity, friction, or air resistance. Force is measured in newtons. It can be measured using a variety of equipment, so force plates and spring scales would be examples of how to measure it. The effects of force can have on an object or body is that it can cause it to accelerate or deaccelerate and therefore move it, and it can cause it to change its shape and the direction it's travelling in. So if a basketballer was going to throw a ball weighing 600 grams and that ball had an acceleration of 30 meters per second squared, it would have a force of 18 newtons, and that's just because force is mass times acceleration.